Hey, it's Ross from rosslukman.com. Today I want to talk to you about how to charge a house battery bank off of your van's stock alternator. We're going to talk about where you tie in to alternator power to pick that up and send it to the back. And we're also going to wire in various relays and chargers and basically take a reading and see how much power we can get through each of these. We've got the Blue Sea Systems ACR relay, we've got the Victron Orion DC to DC charger, and the Sterling Power BB1260 DC to DC charger as well. So we're just going to hook these up and see what kind of power we can get through them. But before we get into that, if you'd like a jump start on your van's electrical system, I have an excellent resource for you called the Ultimate Van Power Cheat Sheet. It's got a discussion of solar power, shore power, and alternator power, and how they all give you a well-rounded power strategy. They all have strengths and weaknesses, and whether you're camping off-grid or plugged in at a campground, they all kind of come together to make sure that you have a charging source no matter where you find yourself out on the road. So there's a discussion on those different power sources. There's also a discussion on different battery types and the strengths and weaknesses of those. That's going to help you get clarity to move forward with a particular battery type that's going to work for your situation. And then lastly, there is an excellent diagram that shows how to network all of the charging sources such as solar, shore, and alternator power, and how they all kind of play nice together, come in there, charge your batteries, and how that gets disseminated out to your end devices such as your phone chargers, your microwaves, air conditioners, etc. So if you've ever wondered how they all work together and how all from your solar panel, all those steps, all the way from your charging sources to your end devices, this diagram is going to give you a lot of clarity around that. So if you'd like to get your free copy, just go to rosslukman.com/vanpower or click the link below to download your copy today. So with that, let's go ahead and install our first device and take a reading. All right, let's take a look at our first device. We have the SI-ACR from Blue Sea Systems. The SI stands for Start Isolation. It's a feature I don't really use, but let me tell you the job of this. So basically, it is going to connect the engine battery, which is that way, to our rear battery bank. And the secret of charging off of your alternator is that you're really just going to connect to the engine battery. You can see this line here, that goes to the engine battery. And the problem with connecting to your engine battery, once you connect it to the rear battery bank, if you start using microwaves and lights and stereos back in the back, as the rear batteries drop, it's going to take the engine battery with it. And so what this does is it has a voltage sensing relay, and as the batteries begin to drop to 13.6 volts is the threshold, basically the relay is going to open its internal switch so that the rear batteries can continue to deplete and the engine battery is preserved so you can start your vehicle. So that's the main job of this. The difference with the relay versus the chargers is it's not going to limit the amount of current. You can think of these cables like water pipes. It's not going to limit the amount of water or the amount of electrons flowing through there. So it's an unlimited flow, and I'll talk about that a little bit later. What I'm going to do, I just want to show you the main circuit here. So as I said, we've got the engine battery coming in. We're going to come in over here and run through a 100 amp fuse and then just connect to system positive, which connects to our battery. And then on the negative, I've got this bus bar here connected to a BMV712. This is a battery monitor, and what I'm going to do with that is take a reading. It actually connects to my phone with Bluetooth, and this is going to tell us how many watts we're getting into this rear battery. So that's why I have this device wired in there. You can see it's got a little positive line that connects to system positive, and it's got a little communication cable that connects to the back of this screen. So it's a little more complicated than I would have liked, but in general, the engine battery comes in, connects to system positive, the electricity runs through the battery, runs out system negative, and then this last negative cable here, this connects to the chassis. And so with alternator charging, you're going to connect your rear system to the chassis and make sure you bolt on to a part of the frame where you've scratched off the paint. Make sure it's bare metal to bare metal so you get good conductivity. and that's going to allow the electricity to flow back to the alternator and engine battery. So in the vehicles, the engine battery and the alternator are both connected. Their negatives are both connected to the frame, and it allows that electricity to flow between all these components. So make sure you got that connection, and then size your lines similarly. So your positive line and your negative line should be the same gauge, because the same amount of electrons are going to flow through there. But that is the gist of it. At this point, let's go ahead, and it's actually connected right now. As this battery drains, it will disconnect. But what we need to do, I'm going to go ahead and start the engine. What we have now is negative 49 watts. So this is like a bank account. If it's negative, it means it's flowing out of the battery. So this battery is actually charging our engine battery right now. But what we're going to do is start the engine, and the power should reverse and begin charging this one. The alternator will charge the engine battery and charge this one as well. So let me start the engine. Alright, so as you can see, we now have a positive 175 watts. It's kind of vacillating a little bit, but about 175, 180 watts, 13 amps coming through, and the battery is currently at 13.27 volts, and the voltage is on its way up. But let's turn the engine off and we'll talk a little bit more about this relay. I wanted to mention one more wire here on the ACR. This is a ground connection, so ground is going to connect to the negative bus, and that gives it a positive and a negative with each battery. So the engine battery is able to take a voltage, and the rear battery bank it's able to take a voltage, and that allows it to open and close the relay. Because it's a voltage sensing relay, it has to detect the voltage of either battery bank in order to do its job. So that's what that wire is for. Now, the main limitation with these relays is, especially with the lithium batteries in the back, if you have a very large battery bank and it's very low, it's run down to say 11 volts, and you start the engine battery and the alternator, a lot of alternators operate around 14 volts. And so if this is 11, it's kind of like two water tanks that are at very different levels. It's going to send a lot of current through to try to level out the two batteries to that voltage. If you're going from a 14 volt system to an 11 volt system, you're just going to have a lot of flow, and what ends up happening is you're going to blow these fuses, especially the one up front by the engine battery. There's another 100 amp fuse, and a lot of people have called me, or a few people have called me when I've put these in, and basically at the end of a long weekend, their rear batteries are really run down, and they discovered that their alternator charging is no longer working. And what it is when the battery voltages are way off and you start that engine, you get so much flow that it overloads the fuses and blows them, and then once the circuit opens and you don't have that connection to the engine battery, everything stops. And so that is really the limitation I've seen with the relays. They're about $80. The chargers are several hundred depending on which one you get. So it's tempting to get one of these, and it'll probably work for a while, especially if your rear battery bank is lead acid, because it's not going to be able to absorb as much power. But once you get into lithium and the larger lithium banks, even some of the lead acid systems I've seen blow these fuses. It just allows an unlimited amount of current, and when the rear batteries are run down, a high current flows and just blows those fuses. So that's the limitation. But overall, a great device. It definitely does its job. It's very high quality, no complaints there. It's just the chargers have a functionality that the relay does not. So let's move on and talk about the Victron Orion charger next. So let's take a look at the Victron Orion Smart Charger. This is a 30 amp charger, and it's the non-isolated version. So what that essentially means is you have one ground that comes out and is bonded to the chassis of the vehicle. And that is the model that I recommend. But basically our wiring is the same. You can see that the engine battery positive is coming in, and we put it in the terminal that says in positive, and then there's one that says out positive, so that's the one that goes out to the rear battery. And then we have our ground. This is the same ground that was bonded to here before, and I just moved it to the actual device. So instead of bonding it to here and then running a small wire there, you just take it straight to the charger. And what this is going to do is, well, first off, I'll mention it has its own Bluetooth connection, so it will connect to the app. Anything with smart in the name from Victron connects to the Victron Connect app. And basically it'll show you what's going on. So right now the charger is off. Actually, let me zoom in and we'll talk a little bit more about this, and then we'll start the engine and take a look at it as well. Okay, so the main screen for the Orion charger is going to show the status of the charger. So right now it says off. It's going to show input voltage, which would be your engine battery, and output voltage, which is what it's putting out to the rear battery bank. So right now it's off, and it's just showing 12.3 volts for the engine battery. And if you go to the gear icon, you can tell it what type of battery you have here in the back. So this is a lithium, and so you go to battery settings. We've got it set as lithium. You can go into the engine shutdown detection, so it will detect when the engine shuts down. Basically, it's going to detect a drop in this input voltage, and once it drops below a certain setting, the charger will cut off, and that will break the link between your engine battery and the rear batteries. And that is similar to the relay in that it will protect the engine battery and not drain it if the engine's off. So that's got the same protection. The main difference though is that it's a multi-stage charger. So you saw that I told it we have lithium batteries, so it's going to send a certain charge algorithm to your rear battery bank. Whether you have AGM batteries or lithium batteries, it's going to send them through a multi-stage charging cycle. So it's going to start in bulk mode, and then absorption mode, and then when they're finished, it's going to go into float mode. And so it's a much more sophisticated charger, and we've gone now from an $80 relay to, I believe, a $220 charger. And the relay was unlimited amperage, unlimited watts. And now this is going to limit it to 30 amps, which is about 360 watts, maybe 400 watts, depending on how many volts your alternator puts out. 360 to 400 watts. So that's about equivalent to one very large solar panel that you're going to be able to get off the alternator day or night. And you're going to be able to see your metrics, kind of see inside the device and what it's putting out. So what I'm going to do now is turn on the engine and we'll take a reading. Alright, so I've turned on the engine. You can see the input voltage is rising and the charger is still disabled. It's waiting. Okay, it's detected that the engine is on and it's gone into bulk mode. And so the output voltage, you can see it climbing here. And that's the difference here. The relay cannot change the voltage of what's coming in and what's going out, whereas this charger, it's getting 13.6 volts from the 13.7 from the alternator, and it's putting out 14.2, so it's actually able to boost the voltage. And then when the rear batteries are full, and let's say the alternator is putting out a higher voltage than the rear batteries need, it'll actually lower the voltage to send to the rear batteries. So it's pretty sophisticated, and a highly recommended charger. But at this point, let's move on and take a look at the Sterling. Alright, so this is the Sterling BB1260. As the name implies, it lets 60 amps come through from your alternator. So the Orion was 30 amps and this is 60 amps. So this is double the power. So we went from 400 watts to approximately 800 watts with this one. I will say you do have the option for a remote. It's about $100. This unit is $425. The remote is an additional $100. And it's a little bit more complicated to program, but basically if you look up the manual, everything's available online, and also the instructions come in the box. But you're going to program it, tell it what kind of battery you have, pretty much the same as the Orion, but you're going to do the programming on the actual unit itself rather than having the smartphone app. But the footprint is about the same as the Orion, and it's going to produce double the power. And 60 amps, in my opinion, is fine for any brand alternator. If you order your van new, go ahead and get the heavy-duty alternator if you can. But 60 amps should be fine for the Sprinter. It should be fine for the Ford Transit or the Ram ProMaster or a Chevy Express like this van. But the good thing about these two chargers is they do limit that current. With the relay, you have unlimited current, and if you have a really large battery bank in the back, you can burn up your alternator. I've talked about blowing these fuses. You could beef up these fuse sizes, but at the end of the day, you have to look at the cable size coming from your alternator into your engine battery. That comes from the factory, and it may not be large enough to handle extremely large currents. So you want to limit the size of these fuses. With this 60 amp unit, they do ask for 100 amp fuses on either end of the line, so you want to put one over by the engine battery as well. With the Orion, you do want to do a 60 amp fuse on either end, and you can use a mega fuse or an A and L fuse. Either will work, but mainly the chargers are going to limit that current, because with the large battery banks in the back, you can burn up your alternator or overload it, and you know, that can be a lot more trouble than it's worth. So in a way, these cost more than the relay, but they're kind of cheap insurance to preserve your alternator and keep the rest of your system out of trouble. One last thing I wanted to mention, both the Sterling as well as the Orion, they have the capability to connect a line from the ignition and be ignition controlled. And that's good to turn these on and off, because they do draw 3 or 4 watts, either model that you get. And so by tying in with the ignition, you can run a wire that's basically has a 12 volt positive voltage whenever the ignition is on. And that turns these on, allows them to do their job. And then when you turn the key and turn the vehicle off, these also turn off. So that would be just one small 18 gauge wire. You would connect it here, and you would connect to your fuse box underneath the driver's seat. And basically you're going to find a fuse that is on or 12 volt positive whenever the ignition is on, and then when you turn the ignition off, it should go dead. But that is an additional feature which I recommend, so that these go on and off with the engine. So here we are underneath the driver's seat. You can see the 4 bolts, and I've removed the seatbelt sensor clip there. I wanted to show you, I mentioned earlier that to connect to the engine battery and engine alternator, you don't actually go out to the alternator. And in most cases, you're going to connect here at the driver's seat. So you can see my red cable coming through from the back. This is the cable that was feeding our relays and chargers. And we have a 100 amp circuit breaker here. I no longer recommend these circuit breakers of this type. You may see these on Amazon. If you're going to use a breaker, go ahead and get a Blue Sea breaker. It's going to be 4 or 5 times the price of this. But some of these do not hold they don't go up to their rating. So this is a 100 amp breaker. To make sure that we get an accurate 100 amp breaker, you want to go with a Blue Sea, or just get the Mega fuse or the A and L fuse that I mentioned earlier, also from Blue Sea. If you use the chargers, your fuses shouldn't blow, because that charger is going to regulate the current going through the line, and it should never get to the fuse rating in order to blow that fuse. But this is an example of a tie-in point. This is the Chevy Express. So with the Mercedes Sprinter, your engine battery is going to be right here in front of the driver's seat, and you're going to have a bus where you can connect a fuse and your cable. The Ford Transit is either going to connect inside the driver's seat base. It'll have an actual sheet metal base, or sometimes they have a connection on the side of the driver's seat. called a customer connection point, or CCP. And then the RAM ProMaster, you can connect either in front at the engine battery, is right here underneath the driver's feet, or they also have a connection at what's called the B pillar, so it would be across the van. Let me see. That way, behind the passenger seat, there's a pillar there, and at the base of that pillar, you can take off an access panel, and there's a place where you can tie in your to pick up alternator power. But basically, I've connected right here. The line comes in from underneath the hood, comes in from the alternator and the engine battery, ties in here to power up these interior electronics. And this is the case with every van. You have a fuse block in here, and this is where the vehicle's internal circuits get powered up from the engine battery. So you just pick up power right there and send it on to the back. I wanted to show you one more thing. I'm going to show you how to get an ignition control wire. You can see this little wire installed here. This is actually my on-off ignition control for the backup camera system. But I'm going to show you, if we put the key in the ignition, this little thing will light up when it has 12-volt power going through it. So we'll connect to ground there. You can see when we start the engine, I don't know if you can quite see that. So you can see that it lights up red when the engine is on. Now let me turn the engine off. It's nothing. Turn the engine on. So that is an example of how you would find a fuse. Basically, it will be 12 volt positive when the engine is on, and it will be dead when the engine is off. And so I was able to locate a fuse. We're not pulling a whole lot of power. We just need to send a small signal to those rear chargers to tell them to turn on. So that it's not, these little wires are not supplying a lot of power. It's just what's called a control voltage. It gets 12 volts when the engine's on, and it gets nothing when the engine is off. So you can do that with the Sprinter and the Transit and the ProMaster as well. Just find the main fuse box just like this. So that was kind of a long one. I hope you got something out of that. Thanks for sticking around to the end. If you'd like more information and a jump start on your electrical system, grab a copy of my Ultimate Van Power Cheat Sheet. Click the link below or go to rosslukman.com/vanpower, one word. Thanks for watching, and I'll see you next week.